Hello, my name is Elias Acosta, and today I'm going to talk about the Sleep Train mattress proposal, in which we designed a type of material to use for mattress in the future. So for our mattresses, we have four categories of materials. We have our ceramics, woods and fibers, polymers, and metals. When looking at woods and fibers, we see that they have no melting point and also no hardness, and they have a very low tensile and elasticity. When looking at the ceramics, we see that they have a very high melting point, which means that they require a lot of energy to break down, as well as they have a very high tensile and elasticity, meaning that they're very hard to break. We also have polymers, which are kind of like cloth materials. They have a very high elasticity rate and a very high tensile strength, as well as a very minimal melting point. And they're not that hard. When looking at metals, we see that they're very hard and they have a range of melting points depending on what type of metal it is. And they also have different tensile and elasticities, as you can see. So when looking at our client's needs, we can see that our client needs something that is soft, lightweight, breathable, and cool. So looking at the four categories, we see that polymers meets all four characteristics, and the red X means that they get cancelled out. So soft materials such as polymers are very soft, lightweight, breathable, and cool. Wood falls short off the lightweight scale because wood is not very lightweight, and ceramics and metals are extremely heavy and not breathable and flexible. So polymers are the best fit because they are not water soluble. In the case that you were drinking a beverage while you were in the bed and spilled it on the mattress, it wouldn't melt. They are also flame resistant because they have an extra chemical added, which is a fire retardant, and they are also soft, breathable, and cool, as mentioned earlier before. And then according to this graph, we can see that mattress grade polymers are basically very elastic and very soft weight and lightweight and soft, compared to other polymer plastics which are extremely hard. So that makes sure that polymer is the best fit. Polyurethane is also a polar covalent bond, as you can see. This is the skeletal structure of it, and it just basically means that there's a bunch of polyurethane joined together with urethane bonds. And finally, here we have a model. We have a model of our compressed figure as well as our uncompressed figure. So basically what this means is that our material is very elastic, meaning that it can be squished and then it can be stretched out again. And one of these boxes represents one of these polyurethane models. So basically after we compress it, we can go back to the regular size, meaning very good for mattresses because people like to jump on them. And that's it.